Welcome back. The circuit is implemented as the servo analog fundamental trainer. This is the analog part. This is the mechanical unit. We are having a DC motor here, and that is output potentiometer showing the response of the DC motor. Here the response is shown on the oscilloscope. This is square input to the DC motor. Here the square input is applied here. This is the square input, and this input is applied to the summer. And here this is the operation amplifier, and this operation amplifier is used as a summer and as a gain controller. So we can change the value of the gain from here. So the value of the feedback resistor is 100 kilo ohm. Here the input value is 100 kilo ohm, so the gain is equal to 1. Now I'm changing the value of the feedback resistor to 330 kilo ohm. So I have changed it to 330 kilo ohm. You can see the feedback resistor, and now you can see some transients in the response. There are oscillations in the response. Now further I'm increasing the value of the gain to 10. So you can see here there are many oscillations in the response. You can see here, and that how it looks like the DC motor is. You can see here the DC motor, and there are, you can see to the output potentiometer, there are overshoots, there are oscillations. So the remedy for this is the PID controller. I'm coming towards the PID controller. Now the upper part is here. This is the differentiator. In the middle there is a proportional term, proportional controller, and here there is an integrator. So I can just change the value of the KD, the value of the potentiometer KD. So and see how we can improve the response. So now I'm changing the value of the KD, and you can see the improvement in the transient response. So that is how you can see that by changing by the value of the KD, the differentiator, the transient response is improved. Now further, if I am interested if there is any steady state error, so I can use the integrator KI, potentiometer P5. So by just changing with the value of the PI, we may have the steady state error eliminated. And we have to tune the PID controller so that the response is the best response. Now you can see here, this is the motor, and the motor response. So that the response of the DC motor is smooth response. There is no oscillation. You can see here in the output potentiometer. And the output potentiometer here is shown here. This is the output potentiometer theta naught. This is the theta naught, and this is the input square wave. And these two signals are provided to the summer. Here OPM is used as a summer, and similarly we can change the value of the gain here as well. So I hope you have understand. Thank you.